Hey, if you're new here, I'm Jake, and today I'm taking a look at Galvanize, which is a company that does boot camps. They offer a few different boot camps, and today we're going to be looking at their immersive JavaScript and Python boot camp. As someone who graduated a boot camp and went on to become a software engineer, I think it's interesting to look back at these, offer a third perspective for those that are interested in maybe attending a boot camp. To go over curriculum and offer insight on, any criticism that I have of the curriculum or what I think that, this program is offering that may be new or super cool or great that you should maybe focus on if you decide to go here. So anyway, take what I have with a grain of salt. I don't know the people at Galvanize. I've never spoken to them. I haven't attended their classes, so I'm purely reacting to their marketing material. Don't want to make this intro too long since I feel like I've gone over this before. So why don't we jump in? This is the Galvanize website, it's thegalvanize.com. You can check that out. They have a lot of different information here that you can check out. Under Hack Reactor Bootcamps, they have a couple different options. I've chosen the Beginner Coding Bootcamps full-time program. Okay, there's the curriculum. So they have a little list here, and then you can download their syllabus. So let's jump into that. So for the syllabus, I think before in the last one I reviewed, I kind of created a list of different things that they were teaching and then ranked them in a way to kind of say what I thought was helpful and what maybe isn't so helpful. With this syllabus, they're actually taking a really interesting approach where they're teaching a lot of different things at a time. So to respect the chronological order that you would be learning this in, instead of creating a list of items and ranking it, that wouldn't really make sense because they teach a lot of items at a time and then they revisit them later. So we're just going to go straight through the syllabus. I'm going to react to it point by point, and then maybe in post I'll add a list. Module 1, Full Stack Architecture. So again, the timing is subject to change. So their website has weeks listed, but this may be different. Okay, so you will get acquainted with your fellow cohort members and learn the structure and rules of the program. You will set up and use a software development environment to initiate and modify a full stack app. You will be introduced to the performance objectives of the module. So you start off learning structured types and basic algorithms. So almost every computation in software engineering is algorithm. Some algorithms like sorting and searching are well known. The feature logic of software applications are also algorithms. Combining the study of what a programming language can do with the study of how to do it is the secret of all modern software. This foundational section focuses on what and how of imperative programming languages. Okay, so this stuff is teaching you data types, it's teaching you variables and flow control structures. Okay. So yeah, this is kind of getting into the nuts and the bolts of just basic flow control of teaching and coding. That's great. That's fine. Start simple. Start with the most basic thing in coding. That makes sense. Okay. Then in the next thing, they have security and REST introduction. The World Wide Web is one of the most successful examples of distributed computing. Fundamental design that allows for success is REST, representational state transfer architecture. And let's see, that's a pattern built on HTTP. Interesting that they're jumping into REST. Most applications use REST and HTTP endpoints, so that's a good thing to teach. I'm on board with that. And then they want you to add authentication and authorization. So this is something I've talked about before. I don't really think that this is super necessary to go into in depth. Use migrations to manage the state of a database schema. This seems a little aggressive for like the second module, or this is still the first module. So, based on this is weeks 1 to 6 in a module. I know it says subject to change, but let's just assume you've been doing this for 2 or 3 weeks. Considering the section before this is just the basic foundations of control flow, to jump right in, I can see how that relates to REST and HTTP. So you understand the basics of control flow. You set up an HTTP endpoint with REST, and that lets you kind of exercise some of that control flow and kind of see the fruits of your labor with setting up a server. Why do we need to know about migrations of the database and SQL at this point? I know that ties into RESTful stuff, but you can still do it. You can still demonstrate the RESTful architecture without a database. All right, I'm getting into the weeds here. I think that this is a weird choice to me to include this so early on. Okay, custom types and structured exception handling. Through the first 2 weeks of the course, we've been using custom types. This formalizes the study of them on how custom types are defined, allocated, initialized. What are we talking about? Classes? Used throughout the running life of a computer program, custom types are also the foundation of a robust exception handling strategy, which must be in place to properly respond to human interaction. By the end of the module, you'll be able to define, instantiate, and use custom types based on functional software specifications. Apply custom types to encapsulate business. Okay, this is just classes. Why are we not using the word classes? Differentiate between the public and private API of a custom type. Apply structured exception handling to return appropriate HTTP response status codes from the HTTP request handlers. Apply structured exception handling in the geographical human interface to prevent corruption of visual state and maintain responsive. Okay, is this whole thing just about error handling? Classes and error handling? This is just a weird structure to teach things in, I guess. I mean, so the very first thing you learn is control flow, and then you immediately use control flow to create a RESTful HTTP endpoint. And then to build on top of that, you're teaching more about error handling here. I would have preferred if they briefed you on what HTTP is, Hypertext Transfer Protocol, so that you understood what that was just quickly, and then talked about how we handle exceptions and errors in the context of HTTP. And then you introduce on top of that REST as a system and how that interacts with HTTP as a system that sits on top of it. It seems weird to go back after you have started learning about database migrations. Again, this is just a very weird ordering of things. Many programming languages support the object-oriented programming paradigm, a way to organize functionality and data that represents abstracted concepts from the real world. Front-end programming technologies are almost exclusively built using object-oriented principles. First-class functions pass function objects as parameters to other functions, declare anonymous functions, describe different types of constraints and indexes used by a relational database. Why are we just dropping in database stuff? This may be just the person who wrote the syllabus. This doesn't seem like relevant to the rest of these things. So I don't understand the relevance of why you would learn this at the same time as this. Rest of this looks good. Basic object-oriented programming in the sense of JavaScript. How does that work? What is it? Why do we use it? Great. You are expected to be able to develop a multi-tier web app from scratch that are able to handle significant complexity of data. Okay, here's the thing. If this is within 6 weeks, you're not doing this. What's probably going to happen is they're going to give like a template, or they're going to give you like a project generation skeleton or something, or something like that, and you'll have a working complex multi-layer web app that you barely know how it works. So I mean, if that's getting your feet wet and getting you getting you comfortable, then that's fine. But this is a little bit of an exaggeration as far as what's expected of you. Okay, let's see. Module 2, distributed applications. While REST was the de facto design standard for web apps, the deep permeation of high-speed internet for internet users has introduced alternatives. Okay. This section introduces setup, config, and access of technologies that provide alternative data access patterns. By the end of this module, you'll be able to differentiate the best uses of REST, RPC, and JSON services as methods of accessing different types of data from a server. Just no. I don't know many companies that use RPC to a point. And then in addition, on top of that, if you need to learn RPC, you can just learn it. But if you have limited time, you should focus on HTTP. Implement RESTful and JSON feed endpoints. In JSON feed, why? I should mention one more time, my reaction is from the perspective of a teaching plan for someone who has a limited amount of time to prepare themselves for interviews so that they have a high hireability and that they know what to do when they begin their job as a software engineer. So while I may be saying, this is ridiculous, why should we learn this? Or this is great, we should definitely learn that. It's through the lens of that. So in the example I just said, it's ridiculous to learn what RPCs are. I'm saying as the first thing you're learning, maybe not. Also, as an extra point, why even bother teach RPCs when I guarantee you the rest of this is all going to be built on top of HTTP REST. Okay, that's my spiel there. Spurred by the introduction of Google Chrome in 2008, focus of web browsers shifted from HTML rendering, speed, code on demand, blah, 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 blah. So this is about React. Okay, again, I don't know a lot about React, but obviously this is a React course. It would be good to spend some time learning about React. Oh, and look at that. RESTful API, no RPCs being used. Interesting. Okay, the introduction of infrastructure as a service through cloud providers such as, I don't like where this is going. Leveraging design patterns from service, a new system design model emerged, microservice. By the end of this, you will need to design and document a robust domain model from a set of functional requirements. Apply the okay, no, you don't need to do this. This is system design. This is something I talked about in my last video. System design is not something you'll be asked about in like introductory interviews for software engineering. It's more of a high level thing. An extremely cursory understanding of this is fine, but to go in to spend any time on it is ridiculous. And the other thing is that to cherry pick microservices as kind of like the hot new thing in the infrastructure area, like why wouldn't you just talk about Docker? I mean, there's 80 other things you could have chosen. Seems just like wasted time. Oh, hey, look at that. Architecture using containerization and orchestration. So now we're getting into Docker. Yeah. Project beta. Okay. Revisit technologies and concepts. You're expected to be able to develop a multi-tier microservice-based dynamic front-end web app from scratch that is able to handle significant complexity in data manipulation and visualization. Bro, this is very complex, very difficult. This is setting the bar like here. So I don't know, it just seems kind of like you're setting people up to fail. Module 3, data intensive applications. Okay, data storage patterns. Up until this point, the only persistent data store use has been traditional relational database. Here's where we get the NoSQL. Modern system design provides more flexibility. The section introduced document-oriented databases and persistent data streams with the ways they can meet the demand of rapid application development and contemporary software development efforts. By the end of this module, you will be able to use SQL data definition language statements to manipulate entities in a relational database, evaluate the use of relational, document-oriented, and stream databases, implement microservices with appropriate persistent stores, research, identify, and evaluate alternate document. Okay, so this is probably talking about like Redis. Again, this is something I discussed in previous videos. If you have limited time and you're concerned with hireability and knowing what you're doing on the first day, simply focus on SQL. It is a very, it's simple to pick up, but there's quite a bit of depth to it. There's quite a bit to understand to it, and you should feel really comfortable and proficient with it before feeling the need to move on to NoSQL variants like document driven or persistent store stuff. If this is important for your first job, then they will most likely be pretty flexible with you learning it when you get there. More often than not, you will need to understand SQL very well. Okay, the WebSocket protocol, again, this is a bummer. This is hard for me too because I love WebSockets, but this is another no-no for me. Let's see. This section introduces the extensions to web browsers and server-side technologies to handle full duplex communication between web client and a web server. By the end of this module, you'll be able to design separate custom data sharing protocols for a microservice-based web app, use the WebSocket DOM API to create a full... Why would you implement backend WebSocket handlers to consume and produce messages? Just no. This is another RPC thing. If you get on the job and one of your the server that you're working with is a WebSocket server, you can learn then. Again, I hate to say this because WebSockets are awesome and I use WebSockets in a lot of projects. I love them. They're awesome. But the problem is this is taking time away from other subjects that are really beneficial for you to study, as far as hireability and knowing what you need to do when you start your job. Formal data structures and algorithms. A common challenge in interviews for software engineering jobs is to solve one or more algorithmic coding challenges. This section gives you strategies for identifying and solving different types of algorithmic problems encountered in software engineering interviews. By the end of this module, you'll be able to mathematically reason about algorithms, use graph-based data models to solve optimization, connectivity problems, use dynamic programming to optimize runtime efficiency of algorithms, categorize or solve a variety of algorithmic interview questions. We're getting to algorithms like 8 weeks in data structures? That seems kind of late. I mean, again, I'm the person who says that algorithms aren't super important, but data structures are. Data structures are really important. So this seems a little late for me. Also, this is kind of smashed. Let's see what the next thing is. The next thing talks about deployment, and then there's a project. So this is module 3. And again, if we look here, modules are about a month long. So are they expecting to cover algorithms and data structures in a week? If you have a 19-week program, I would expect at least 2 or 3 weeks to be on data structures and algorithms. Let's be realistic here. This is not enough time to get a grip on data structures and algorithms, and that will be an important component to your hireability. If not algorithms, then absolutely data structures. Dynamic programming would be pretty important. Again, this is funny for me to say coming from the person who's not super interested in algorithms, but this seems like a big miss. With a 19-week program, you have a little bit more room. We could maybe drop the time spent learning about WebSockets and RPCs and spend a little bit more time digging into time and space complexity. Optimize runtime efficiency, I guess that's what that is. So yeah, little bummer here. I would have liked to see this be more prominent. All right, real world deployments and securing networks. Getting production ready apps into production is the goal of every software engineering team. Doing that reliably and consistently has created interdisciplinary roles such as DevSecOps and site reliability. Yep, this section introduces the best practices for getting code from a software developer's computer into a secured production environment using automation through continuous integration delivery pipelines. So yeah, they're going to talk about CI/CD pipelines, containerization. Again, this is just, not only are you never going to get asked about this in an interview, like they might it might be just a cursory question. Have you ever used a CI/CD pipeline? Do you know what that is? Have you worked on a project that's used that before? That might be a question you get asked, and you can just say yes or no. It's not really important. It's not going to make or break an interview, I don't think. So it's not wasted learning on your free time, but as far as like a limited time to learn things, this isn't going to be an integral part of your hiring process, and it's probably not really going to take a very big, it's not going to be a point of importance during your first experiences as a software engineer. So then this project is Project Gamma. You'll be expected to develop a multi-tier microservice-based dynamic front-end web app from scratch that is able to handle significant complexity, blah, 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 blah. You're expected to be able to deploy it to a cloud provider. You'll be able to collaborate with one another using Git and project management. Yeah, this is just adding more stuff to the absurdity of the previous projects. I mean, maybe I'll give the benefit of the doubt and say that they allow you to continue using the previous projects and then iterating on it to build. In that case, adding new things to it is going to be easier than starting from scratch. But I still maintain my initial point that the expectations were set a little ridiculously high in the first place. I would think it would be cool to just give them an existing project that ran, like a sample thing that was completely built, and then say, build out the CI/CD pipeline. Add the configuration files, set it up with the provider. I think that's more than enough for like a 1-week project. Okay, module 4, this is the last one. This is the hiring sprint. So we learn how to apply for jobs. We learn about the job search process, and finalizing the portfolio, interview skills, brushing up on fundamental computer science, i.e. the 1 week of algorithms and data structures that we talked about, and then problem solving concepts. Prepare to apply to a software engineering position with guidance from instructional staff. You are expected to have a holistic understanding of the job search process. Okay. Yeah, this is good. This is going to be, I guess, according to this, it's probably going to be a couple weeks. I think that's fine. That's good. Having you practice interviews with people is good so that you feel comfortable in the interview process, and it gives you an opportunity to practice interview questions. I would encourage you to join LeetCode or AlgoExpert or something like that, and actually up your data structure and algorithm understanding for that process so that you're prepared for your interviews, because this, as we saw, did not give enough time, in my opinion, to that. Okay, well, I don't want to spend too much time on this. I think to wrap it up, I'm sorry that I don't have a graphic to kind of show what's good and what's bad about this, so I'm just going to zoom through everything real quick and just say things that I would focus on and things that I would not focus on. Let's see. So going through here, the basic built-in structure types and basic algorithms. This is like code flow. That's super important. Security and REST introduction. I think this is a really weird module. I don't like the construction of it, but some of these are important concepts. Custom types and structured exception handling. This is about classes and HTTP exception handling. That's good stuff to know. Again, weird order, but good to know. Object-oriented programming is important. You need to know how to do that. Data access patterns. So this is kind of a weird one. I would not really put a lot of effort into this, REST is important. RPC and JSON services it is not super important. And this goes along with the WebSocket stuff. React and front-end state management, probably good to spend a lot of time and effort learning about this. Microservices and system design, you could completely skip this. It's not going to be relevant to you as a beginning software engineer. Let's see. Data storage, focus on SQL. Just ignore NoSQL stuff. It's just not worth the time to get into in a meaningful sense. Ignore the WebSockets. Spend a lot of time on the data structures and algorithms. You have a lot more time in this program compared to other programs I've looked at. Spend that extra time getting teacher resources to help you with data structures and algorithms, which are a complex concept that you need time and help to absorb. Real life world deployments and securing networks, maybe just a cursory understanding, but I wouldn't spend too much time on this. And in the hiring sprint, this is all good stuff. So take care of this. Make sure you get lots of practice in practice interviews. Make sure you learn how to make your profile look nice and send out applications. That's how you get your foot in the door. That's how you get your first interview scheduled. Once you get to your interview, it's going to be all on you, your practice, your experience to feel comfortable and execute. And then when you get there on your first day, hopefully all these things that you've studied will hold you up. I would say in total, this is a really interesting syllabus and curriculum. I don't think I really approve of the ordering of things. And but even more than I don't approve of the ordering of things, which I think I can let go, is just it feels like they put extra time into this, which is great because these are complex subjects we need time to learn about. But instead of using the extra time that they put into this to make it 19 weeks and really buckle down and focus on understanding the concepts, they just added more subjects. Like things like RPC, WebSockets, NoSQL, things like that. I think you could have left those out and then used that extra time to produce students that had really strong core understandings of concepts that would help them nail the interview and then also show up as really competent workers on their first day. So that's kind of a bummer. That being said, again, I've never spoken to the people at Galvanize, never spoken to the people who went through the program. Take everything I say with a grain of salt. I just have this material to react to. So that's all I have. Again, thanks for watching. Let me know if there's any other syllabus or curriculum you want me to react to. And then, subscribe to the channel for more. So thanks.